Good evening, everyone, and this is Josh Steiner, your forecaster. Um, all right, let's begin with our analysis of the storm. We'll begin with the surface chart. As you can see, the primary low from yesterday it moved into eastern Tennessee, actually, as I said, but then it quickly transferred off to the South Carolina coast. Right now, we have a situation where it's beginning to rapidly intensify as it um, interacts with the warm Atlantic waters. As you can see, oops, uh, pressure falls along the northeastern periphery of the storm are pretty intense, below negative or below 3 millibars in 3 hours, or in 2 hours, which is pretty decent. Um, let's go to surface observations. Okay, so we have a lot of uh, colder air on the backside, lots of 20s and lots of 20-degree temperatures extending all the way to Alabama, which means this whole area right here is all snow, or basically almost all of it's snow. Um, as you can see, there's some dynamic cooling along the western periphery of the storm has dropped 850 millibar temperatures down to almost -10, which is sort of helping to intensify snow ratios. Um, on the northern periphery of the storm, however, we have much more heavier snowfall rates, uh, especially as this secondary low off the coast intensifies. These bands will continue to intensify. Um, However, as you can see, snow along the western edge of the storm has actually begun to dissipate. Um, Earlier today, there was much heavier banding across southern Ohio, West Virginia, into Kentucky, but now it has sort of weakened and moved off to the east along with the energy transfer. um, so, as you can also see, there is a lot of convective development has occurred, and this is mainly because of higher mid-level lapse rates over this region. You'll see this region over the dry slot that's making its way into uh, West Virginia and Kentucky and parts of the Tennessee actually has some very intense 700 to 500 millibar uh, temperature decreases at 7 degrees Celsius uh, per kilometer. Um, Also, we have the problem of another dry slot that's making its way into Virginia and parts of uh, North Carolina. This isn't too concerning because, as you can see, precipitation is starting to rapidly fill in, as this is one of the regions where strong upward vertical velocity is occurring. Just to the north, we actually have a jet streak still helping to aid in this upward motion, as well as a more mesoscale jet developing right here along the edge of the coast, probably mainly due to latent heat release. Now, as you can see from the 300 millibar map, the storm hasn't actually closed off as we were anticipating it to close off. It looks like it may do so within the next few hours. However, this might present a problem for model forecasts that we're predicting it to close off. As you can see, uh, we have a couple of vorticity lobes in the main trough itself. We have one that's strongly negatively tilted right here off the coast, which is helping to power the main storm, sort of raising ridge heights in the mid-Atlantic. It's one of the main reasons why this storm should slow down as it strengthens off the coast. We also have another short wave back behind the trough, which may help to enhance snowfall rates for a short period or late tomorrow as the storm begins to exit the coast. It'll also probably be one of the reasons why the low actually begins to close off later on. Um, let's take a look at some frontogenesis. We have some pretty intense frontogenesis right here along the coast. The 925 millibar map, which indicates strong vertical velocities. Now, since air since air usually rides up along isentropic surfaces or surfaces of or lines of equal potential temperature, there's a lot of upslope flow going on right here in the low to mid levels onto up into the mid levels from the ocean waters up into the mid levels, which is sort of helping to generate this very broad area of heavy snow across the mid Atlantic. Take a look at 850. As you can see, you have some more disorganized phronogenesis, but it's still helping to contribute to banding in several locations, especially this area right here in West Virginia. However, the bigger concern is actual convection developing and moving into the cold air, which will help to provide a chance for even some thunderstorms in the main snow regions. And so here's a look at the potential vorticity map. You can see where the strongest broad area of upper level upward velocities is occurring. It's occurring in that dry slot behind the storm, which should sort of fill in as it begins to travel to the north and east. But basically, the orientation of this lobe of potential vorticity is the reason why I do expect that the northward shift on the models will verify. I know there hasn't been much northward shift over the last few hours, but the northern edge of the virga of this precipitation has almost reached New York City, which is fairly significant. Either way, that's my analysis. Let's take a look at some of the shorter range models like the 4 kilometer NAM. Let's do the full CONUS. So this is a simulated radar. We have this sort of moving up the coast over the next several hours. Finally bringing heavy banding by tomorrow morning into well, this isn't very accurate. I should probably not use that. We'll use the regular name. Sector view. All right, so we have this. So in the overnight hours, we have this precipitation expanding into the northeast. New York City should start snowing in New York City and places around that region by midnight tonight, according to the 18Z NAM. As we go into the overnight hours, the storm continues to expand northward. The NAM is the furthest north of the models, I believe. However, I don't think its scenario is out of the question. So we might even get some good accumulating snow up into Connecticut and Massachusetts, as our weather optics forecast has now indicated on our maps. But either way, it looks like we could see some fairly intense banding tomorrow morning, especially in Maryland and southern Pennsylvania, and then upwards into New York City, or just south of New York City by early afternoon. And by late afternoon, it tries to move into the deformation zone begins to move through eastern Pennsylvania, New Jersey, southeastern New York, and extending into Maryland and West Virginia. And this sort of lingers around for a while. And it's sort of uncertain as to what exactly the deformation zone is going to do, because they have been known in the past to bring surprisingly heavy snowfall, especially with the fact that dynamic cooling from the storm system should enhance snowfall ratios towards the end of the system. So whoever is the lucky winners of being able to sit in that band will probably see the highest totals of the storm, especially in southern Pennsylvania, southeastern Pennsylvania, into Maryland. And as you can see, the storm kind of sits off the coast, according to the NAM, and sort of brings some heavier snow even to Cape Cod and those areas. eventually it makes its way off the coast by Sunday afternoon, and all precipitation exits the region. And that's basically all I have. In summary, basically we have this primary low is currently transferring to off the coast. It should begin to strengthen. The storm should move northward, and based on the current trends, I am expecting that the models who did trend north today, the short range models especially will probably verify, given how the storm is currently developing. We'll keep an eye on the storm as the evening progresses.